Good morning, students. Our next topic is window to viewport transformation. Basically, basically, class, what happened? We are in the previous weeks we discussed clippings, various types of clippings, but during these courses, during these lectures, what we discuss how we clip a line, how we clip a polygon, how we clip a point, how we clip a characters. But in all these lectures, we discuss windows, a dotted window. Class, basically in every graphics package, it allows a user to specify which part of a defined picture is to be displayed and where that part is to be placed on the display device. In all these lectures, the part of that object you want to display, only a selected part. That selected part is selected with the help of window. After selection, after performing clipping, what you did? You did that part is to be shown on your display devices. How these actions are performed? These actions are performed, these actions are mapped from window to viewport. Those parts of object which are in the window, now they are mapped to a viewport. So this is called as window to viewport transformation, right? Now class, in every graphics package allow a user to specify which part of a picture is to be displayed and where that part is to be placed, right? What part of a picture is to be displayed, they are selected by window. Means a world coordinate area selected for display is called window. The window defines what is to be viewed. Means उस पर्टिकुलर ऑब्जेक्ट में से कौन सा पार्ट आप देखना चाहते हो, उस पार्ट को आप लोग कैसे सिलेक्ट करोगे? विद द हेल्प ऑफ दैट डॉटेड विंडो. नाउ आफ्टर परफॉर्मिंग क्लिपिंग, those part of a picture which is inside the window, now they are mapped, now they are displayed on your display devices. That is called as viewport. An area on a display device to which a window is mapped is called viewport. So viewport defines where it is to be displayed. Where means that part which is selected in the window, at what position it is to be displayed on your display device. That is called as viewport. Look at this example, class. This is the black one. This is a black image. Only we want this part is to be displayed. So this rectangle window we placed on that object. After clipping, only that part of an object is to be displayed on your viewport. So this is your viewport. So when the original picture is shown with the help of world coordinates, That's why this window boundary, with this window having a boundaries x w minimum. The reason is w stands for world coordinates, x having the coordinates minimum. This is the minimum range and this is the maximum range. Same in terms of y coordinates, this is your minimum and this is your maximum. Y w maximum, w stands for world coordinates. Same, when these boundary edges are mapped into the viewport, they are called as device coordinates. Same, the viewport having xw minimum, this is the minimum range and this is the maximum range. Again the your y minimum range and this is the maximum range. How this window is mapped into the viewport, this is our main topic. So this is very important topic also, and there is a derivation in this topic. Now our topic is window to viewport transformation. Class, sometime we called it as windowing transformation. The mapping of a part of a world coordinate scene to device coordinate is referred as viewing transformation, or sometimes this two-dimensional viewing transformation is called as window to viewport transformation, or it is also called as windowing transformation. Now look at this example, because in the previous example this is a biggest figure. We start with the small point, right? Now we want to map this point object which is placed inside the window into the viewport. See class, this is your window, right? This is a window. They are having a coordinates xw minimum, xw maximum. This is yw minimum, this is yw maximum, and this point having coordinates xw yw. Why we are placing w with the x and y coordinates? Because these objects represented with world coordinates, right? Now our main motive is how we map this point from window to viewport. Means we have to calculate xv and yv. This viewport having the edges xv minimum, xv maximum, yv minimum and yv maximum. Why we are putting v with x and y coordinates? Because it's a viewport and they are converted with the device coordinates, right? Now xw yw, a point on window, they are represented with a point on window. Xv yv, a point on viewport, right? Now our question is how we map a point at position xw yw in the window is mapped into the position xv yv in the associated viewport. So when we map this point inside the window into the viewport, the same relative placement of an object in the window is maintained in the viewport, only size will be reduced or enlarged. Means in window to viewport transformation, if you remember, we perform relative fixed point scaling, right? Scaling means either you want to enlarge the size or you can decrease the size, right? Class, this is the derivation of this topic. Now our question is how we derive this equation. Class, our main question is, I will discuss you. Class C. First we discuss this difference. How we represent this difference? This is XW, right? This is viewport, right? Out of this window means we have this marks out of this, right? Because we are mapping, so we have to place one side viewport, another side window, right? Now our question is how this equations will come. This is XW minus XW minimum. मेरे पास ये आया, ये वाला डिफरेंस कैसे आया? XW माइनस XW मिनिमम. दिस किस में से आया? XW मैक्स माइनस XW मिनिमम. मतलब इतने में से मुझे सिर्फ ये पार्ट दिखाना है, इतना बार, राइट? क्लास ये क्लियर है, ये वाला चीज़, ठीक है जी. अब जब विंडो हमारे पास आ गया, अब व्यू पोर्ट सेम, ये चीज़ मेरे पास आई XV माइनस XV मिनिमम, ये मेरे पास चीज़ आई आउट ऑफ दिस, राइट? XV मैक्स माइनस XV मिनिमम. क्लास ये भी क्लियर हो गया. सेम in respect to y coordinates, right? yv minus yv minimum, this is, इसकी बात कर रहा है. yv minimum ये कैसे आया? out of this yv max minus yv minimum, ये वाली बात कर रहा वो, right? Same in respect to window, yw माइनस yw मिनिमम, इसकी बात कर रहा वो, ठीक है जी. आउट ऑफ yw मैक्स माइनस yw मिनिमम, राइट? दिस इज अवर स्टार्टिंग इक्वेशन, राइट? क्लास, नाउ सी, we have derived this equation to this picture. Same, we write these these x equation here. Now we want to interchange it. Maths allow us, we can interchange. XW goes to this side, XV max goes to this side. Class clear in this equation? We put XW put into here and XV max we put here, right? Now we go for y coordinates. This complete equation we put here. Now interchange, like x we interchange y. YW go to this side and YV max go to this side. This is after interchanging this equation, and this new equations will arrive. Now we already discussed in this window to viewport transformation we perform scaling, so we need scaling factors. This Sx in your topic, Sx represented by this xv max minus xv minimum over xw max minus xw minimum. This is our formula, right? Okay, and same sy scaling factor in respect to y, yv max minus yv minimum over yw max minus yw minimum. This is our scaling factor sy. Now put sx and sy in the equation 1 and in the equation 2. Now this complete equation is replaced with Sx, and this complete equation is replaced with Sy. Class clear hai? Now because we want to derive xv and yv, right? Now in this equation, this xw minus xw minimum goes to this side, and when it goes to this side, it is multiplied, right? See, in this, when it goes to this, it is represented like this. Y goes to this, it is represented with this. Now our main question is, we have to derive xv and yv, right? In this equation, this xv minimum, when goes to this side, it is represented with plus sign, right? Xv, and this equation, xv minimum goes to this side, and it is plus, and yv, again yv minimum goes to this side, it will represent it with plus. Now at the last, you see your xv and yv will find out with the multiplication of scaling, because in this representation we perform scaling class, scaling transformation.